All right, let's dive into a concept that's absolutely crucial for making software fast: database indexes. Seriously, if you've ever found yourself staring at a loading screen, wondering why an app is taking forever, well, the solution might be right here. Let's get into it. So, let's kick things off with a problem that I know we've all run into. You run a query, and you wait. And you wait some more. Why does it sometimes feel like your database is trying to read a 10,000-page novel one single word at a time? You know, that painful, frustrating slowness is exactly what we're going to tackle today.
And this, right here, is the perfect way to think about it. Searching a database that doesn't have an index is just like trying to find one specific sentence in a massive book by literally flipping through every single page. It's brutal, right? But with an index, it's like you just flip to the back of the book, look up your topic, and it tells you, hey, go to page 742. It's a targeted, super fast shortcut.
So yeah, that shortcut we were just talking about, in the world of databases, that's exactly what we call an index. And you know, while it isn't actually magic, sometimes the performance boost feels pretty darn close.
So, what is it really? A database index is basically a separate, super organized lookup table. It takes the values from a column you care about, sorts them, and then creates these things called pointers. Just think of them as little addresses that point directly to the full row of data in the main table. The whole point, the entire goal, is to avoid having to do that slow, painful page-by-page reading of the whole table.
Okay, so let's walk through how this actually plays out. First, you decide to create an index on a specific column, let's say the last name column in a user table. The database then goes and builds this special, sorted lookup table just for last names. So now when your code asks, hey, find me everyone with the last name Smith, the database doesn't even bother scanning the huge user table. Nope, it zips over to the tiny, sorted index, finds Smith in a split second, grabs those pointers, and then uses them to jump directly to the right rows. The difference in speed is just massive.
All right, so that's the what. We get it. It's a shortcut. But what about the how? How does it actually work so efficiently under the hood? What's the secret sauce that makes that lookup process so incredibly fast?
Well, the real magic isn't just that the database creates a list, it's all about how it structures that list. So what's the actual technology that's powering this incredible speed?
For most databases, the answer is a brilliant data structure called a B-tree. Just think of it like a perfectly organized digital filing system. It's self-balancing, which basically means it's constantly tidying itself up so that it never gets messy or deep in one area. This ensures that searches are always fast. In tech terms, we call that logarithmic time, but honestly, all you need to know is that it means the search time barely goes up even if your table grows from 1,000 rows to 10 million. It's an amazing piece of engineering.
Now, just like you wouldn't use a hammer to saw a piece of wood, you have different kinds of indexes for different jobs. And picking the right one, yeah, that's crucial.
So let's break down the two main types you're going to see. First up, the clustered index. This one is a big deal because it actually dictates the physical order of the data on the disk. Think of a dictionary. The words themselves are physically stored in alphabetical order. That's a clustered index. And because it controls the physical layout, you can only have one per table. Then you have the non-clustered index. This is much more like the index at the back of a textbook. It's a totally separate structure with page numbers, or pointers, that just references the data, but it doesn't change the order of the chapters themselves. And because of that, you can have a bunch of these on a single table.
Okay, so knowing what an index is and how it works, that's really only half the battle. The other, arguably more important half is knowing when, and maybe more importantly, when not, to actually use one.
And here it is, the big trade-off. Because there's always a trade-off, right? The upside of an index is obviously dramatically faster data retrieval, or reads. The downside? Well, every single time you change the data, an insert, an update, or delete, the database doesn't just have to write that change to the table, it also has to update every single index. This makes your write operations a little bit slower, and of course the indexes themselves take up extra storage space.
So, what are the rules of the road for smart indexing? Well, first, you really want to focus on the columns that you use to filter, connect, and sort your data. Think of your where clauses, your join conditions, and your order by clauses. Second, you want to prioritize columns with what's called high cardinality, which is just a fancy term for columns that have a lot of unique values. An email address column or a user ID column, perfect candidates. But a gender column with maybe only a handful of options, not so helpful, because the index can't really narrow things down for you. And finally, you have to monitor your indexes. Make sure they're actually being used and are still effective.
And that brings us to, without a doubt, the single biggest mistake people make: over-indexing.
just adding an index to every single column because you think it'll make everything faster. Remember that trade-off we just talked about? Doing this will absolutely slow your write performance to a crawl, and just waste a ton of disk space for almost no benefit. When it comes to indexes, more is definitely not always better.
So the real key takeaway here is that a database index is an incredibly powerful tool, but it's not a magic button you can just press to fix everything. It takes a little thought and a little strategy. So the next time you're facing a slow query, don't just sit there and wait. Think about the structure of your data and your queries. The answer might just be an index away. So let me ask you, are you using yours wisely? Thanks for joining me.